Okay, welcome students. In the previous case, we studied about a quantity discount models with a single price break. So these are the assumptions, these are the formulas, and these are the applications like that we discussed. Okay, right now there is another type of price break problems or quantity discount models. This is a quantity discount models. There may be a discount according to the quantity. Such mathematical models we are framing there with the double price break. What is the meaning? Double price break. Look at this. If we buy any item in this particular limit, then the price break is K11. Okay. Now, if we buy a quantity between these two limits, then this would be the price break. Okay, so there are two slabs are there. If you buy in this quantity, this would be a price break. If you buy this quantity, then that would be the price break. If that is the case, then what would be the corresponding formula, mathematical models? Okay, the assumptions are as before. Demand rate R, purchasing cost K, holding cost P, setup cost or ordered cost C3. Okay. Now the formula is given by Q2 optimum equals square root of 2 into C3R divided by K12 P. So all are given here. Am I correct? K12 is given here. C3 is setup cost or ordered cost, and R the demand rate, and P the holding cost. So everything is given to us. So just by substituting those things in this particular formula, we can get what is Q2. Right. Similarly, by applying all the values in this particular formula, we can get the corresponding optimum cost. Optimum cost corresponding to this particular quantity that we are calculating. So the formulas and those are very important here. That's what we have to understand. Okay, right. So now what we understand here is that this is what the assumptions for this model, and these are the model structure for this quantity lying between this is the price break given to us, and if we buy the quantity between these limits, this would be the price break. If that is the case, we have to calculate this. Then after calculating this, we can substitute all the requirement here is already available, nothing is unknown. By substituting this, we can get the optimum cost. Okay, right. So before that, we need some algorithm for that. In this particular method, there is an algorithm to solve a double price break. Okay, what is the algorithm? The first one is that we have to compute Q2 for K12. This is the Q2 formula. For K12, in the place of K12, all other values as it is, we have to calculate Q2. Okay, Q2. Right. Then that is the first step we have to calculate. The second step is that we have to compare Q2 and B1. Q2 is by calculations. B1 is limit is here. It will be given. So when the problem comes, I will explain you. Okay, this is this particular place corresponds to B1. So we are comparing this value with this B1. The third step is that if Q2 is greater than B1, then EOQ is Q2. Then EOQ, economic order quantity, is Q2. So we have to compare this and this. If this is greater than this limit, lower limit, then this would be the economic order quantity for the given situations. Okay. So now let me take one problem for you. And if I maximize, then it would be easy to look at. Now look at that. Now a pen making company purchased 2,400 kilogram of chemicals over a period of 1 year, that is 360 days. Okay, Right. These chemicals undergo discounts as follows. A pen making company purchased 2,400 kilogram chemicals over a period of 1 year. These chemicals undergo discounts as follows. This is a discount given to us. Okay, right. So if we buy the quantity between 0 to 500, okay, then above than 0 and equal to 500, and I must write here equal to 500, then the price break is rupees 1000. Price breaks, that is discount, is rupees 1000. Suppose it goes more than 500, then the discount is 950. Discount is 950. If this is the case, then how much we have to order? How much kilogram of chemicals we have to order? That's what the situation is. All these components are given to us. Cost of the ordering is rupees 70,000 given to us. Cost of storage is 0.1 percentage, and we have to find the economic order quantity or economic lot size or UOQ, anyway we can say, and we have to find the corresponding optimum cost also. So look at that. The formula we have to apply here is this. First we have to find out this Q2, then this and this we have to compare. That means in this particular problem we have to calculate Q2. After calculating Q2 we have to compare with 500 because B1 is 500 here. Okay, so first step, let us calculate what is Q2. With the same formula given here, Q2 equals square root of 2C3R divided by K12P, we can calculate Q2, okay, where R is the demand rate, K12 is what purchase cost, and this is holding cost, so this is setup cost. So all this we are substituting here to get 905 or 905 kilogram as in the previous case. So this is what the kilogram we have to buy in order to get the optimum value. Now what is next step? Comparison of Q2 with B1. Now Q2 we have calculated as 905, but what is B1? B1 is 500. So B1 is 500 and Q2 is 905. So definitely Q2 is greater than B1. Q2 is greater than B1. Therefore, the Q2 is the optimum quantity that we have to order to get the optimum cost. So optimum order quantity, that is economic order quantity, is 905. Then again, by using this particular formula, as we have discussed just before, to find out the C naught, we can, same formula is applied here. This formula is given, you substitute those things, you'll get 1,125 rupees. 1,125 rupees. So this is what optimum cost, this is the optimum quantity. So this is a way we can solve the second type of problem. What is the second type of problem? Is a discount quantity discount models with the double price break. Okay, so with that we come to the end of this session. The next session I will take in another problem. Thank you.